In this video, we'll talk about how to perform statistical inference on categorical data when we have more than two groups or categories. We've previously seen how to use normal distributions to perform inference on categorical data with only two categories, and here we'll extend these procedures using a new kind of tests known as a chi-square test. In these videos, we'll talk about how to use chi-square tests to test for differences in proportions for categorical data with more than two groups or categories, how to determine whether it's appropriate to use a chi-square test in a given context, and how to interpret the results of a chi-square test. The Greek letter that you see on the slide is, of course, the Greek letter chi. We'll refer to an example from a 1992 study by Chase and Dummer, who asked a random sample of students in grades 4 through 6 in the state of Michigan which they thought was most important: grades, being popular, or playing sports. We'll look at whether we have evidence that priorities are different for 4th, 5th, and 6th grade students, and also whether priorities differ depending on whether the students were in rural, suburban, or urban school districts. We'll start by looking for differences between the grade levels. As we saw before, our null hypothesis will be that there are no differences in preferences for 4th, 5th, and 6th graders, and our alternative hypothesis will be that there are differences in preferences between the grade levels. We now have three different grade levels to consider: 4th, 5th, and 6th grade, so the two sample procedures that we've seen previously won't work here. Let's take a look at the data. In the upper table on the left side of the screen, we have the number of students in each grade level who chose each priority, either grades, popularity, or sports. We can see that among 4th graders, 63 students said that grades were most important, followed by 31 said being popular was most important, and 25 students picked sports. For 5th graders, the numbers were 88, 55, and 33, and for 6th graders, 96, 55, and 32. Because we have different numbers of students in each grade, it's hard to compare those numbers directly, so it's more useful to look at percentages, which are shown in the lower table. We see that for 4th graders, 53% preferred grades. For 5th graders, 50% preferred grades, and for 6th graders, it was 52%. Popularity was second for all three grades, followed by sports. On the right is a graphical breakdown. We can see that for each group, grades were most commonly picked. The bars of the graph appear pretty similar for the three different grades. Maybe a little bit of a difference with 5th graders seeming to pick popularity a little bit more than the others, but to me those bars don't look all that different. The question we need to think about is it reasonable that we could have gotten differences like we see here just by chance alone, or do these data provide evidence that there really are differences in the way that 4th, 5th, and 6th graders perceive the importance of grades, popularity, or sports? Like we've done before, we'll use a statistical test to check this out. And the appropriate test to use when we have multiple categories is a chi-square test. A chi-square statistic tells us how different the proportions are across groups. The larger the chi-square value, the stronger the evidence of the differences. It's appropriate to use a chi-square distribution when each cell in a table has at least 5 observations. Since we have more than 5 observations, way more than 5 in each cell in the table, it's reasonable to use a chi-square test in this setting. We won't talk about how to actually compute the chi-square statistic here, but the textbook has an explanation if you're interested in looking at that. Instead, we'll use R to calculate the chi-square test, and it calculates a chi-square value of 1.31. Now, we don't really know how big is 1.31 until we compare it to something, and in this case we'll compare it to a chi-square distribution, which you see shown below, and our value of 1.31 does not look very extreme at all. If we look at the probability of getting something more extreme than 1.31, which in a chi-square distribution means to the right of 1.31, that probability is very high. In fact, from the R output, we see that that p-value is 0.8593, a very large p-value. Thus, we don't have evidence to conclude that there are differences between the grade levels. It would not be at all unusual to observe differences as extreme as we did in the table just by chance if there really were no differences at all between all 4th, 5th, and 6th graders. And if we look back at our data, again, the differences appeared to be very small, so it's not surprising that we would fail to conclude that there are differences between the grades in this situation. Now let's think about whether there are differences between the locations of the schools. Our null hypothesis will be that there are no differences in preferences between rural, suburban, and urban settings, and our alternative hypothesis is that there are differences between the settings. If we take a look at the data in this situation, looking at the graph right away, we see that the rural students tend to look different than the suburban and urban students in terms of their priorities. It seems like for rural students, there's about an almost equivalent number choosing sports, popularity, and grades, while students in suburban and urban settings seem to choose grades more frequently. Looking at the table, again, we see the percentages are pretty much the same for urban and suburban students, but for rural students, only 38% said that grades were most important. Let's test whether these differences are statistically significant. That is, whether there's enough evidence to say that for all students at least in Michigan, where these data were collected in the early 1990s, that we would have evidence of differences between rural, urban, and suburban settings. Again, we'll use a chi-square test, and notice that the chi-square statistic this time is much larger. It's 18.828. If we look at where that lies on the chi-square distribution, it's way out in the tail. It's very extreme. The probability of getting something more extreme than that, the p-value is very small, 0.0008. Therefore, we do have evidence to conclude that there are differences between the settings. Again, this study was conducted in the early 1990s using students in the state of Michigan, so we should be careful about generalizing our results beyond that or concluding that the results necessarily would hold today. In this video, we've talked about how to use chi-square tests to test for differences in proportions for categorical data between two groups or categories, how to determine whether it's appropriate to use a chi-square test in a given context, and how to interpret the results of a chi-square test.